I'm excited to welcome Richard Socher. Richard is the founder and CEO of U.com, the search engine that puts you in control. Your sources, your time, your privacy. Richard previously served as the chief scientist and EVP at Salesforce. Before that, Richard was the CTO of AI startup MetaMind, acquired by Salesforce in 2016. Richard received his PhD in computer science at Stanford, where he was recognized for his groundbreaking research in deep learning and NLP. He was awarded the Distinguished Application Paper Award at the International Conference on Machine Learning 2011, the 2011 Yahoo Key Scientific Challenges Award, a Microsoft Research PhD Fellowship in 2012, and the 2013 Magic Grant from the Brown Institute for Media Innovation, and the 2014 GigaOM Structure Award. He also served as an adjunct professor in the computer science department at Stanford. Richard is joined by Russell Kaplan, Director of Engineering at Scale. Russell, over to you.
Richard, thank you so much for joining us again at TransformX. You are such a prolific, well-known figure in the AI community. You've been doing extensive research in the area of natural language processing, healthcare. You've been doing a lot of this stuff before it was cool, deep learning for NLP, really early with formative results. And you've also been doing this while now building a company, U.com, stewarding investments with AIX Ventures. How are you doing it? What's driving you?
I'm actually really excited about AI. I love the impact it can have. I think we're currently at an inflection point for humanity, and I'm excited I can be a part of it and sort of help it from the research side, on the startup side, large companies investing in the ecosystem, and helping other founders maximize their impact, just like I'm trying to maximize my impact. So it's a really exciting time. There's only so often when humanity kind of finds a new technology, like moving from hunting and gathering to agriculture and being stationary, the Industrial Revolution, the internet, and electricity and electrifying like different industries. And now we're seeing that same excitement and increase in human productivity through AI. And so I've always been, had my lazy moments where I had to take out the trash or mow the lawn or sweep the, leaves off. And I'm like, this is just such a waste of time. This is such a not fun thing for me to do right now. I wish there's some automation for this. And so I do think people will be able to do a lot more interesting things when the very boring ones go away. And that is not always going to be easy, I think. And it's non-trivial socially and politically sometimes. But ultimately, 150 years ago, over 90% of people worked in agriculture, and now it's about 5, at most 10%, depending on the country. And most of those people that are currently not doing that and having other kinds of jobs in marketing or research or sales or something are probably happy not having to work in the field manually every day. I think that moving forward in time will also be the case for AI. Looking back, people are like, oh, this is currently a lot better. That being said, in those transition phases, we do need to be very careful and very thoughtful about how we transition the world into that new era of more and more AI jobs or AI-powered jobs.
Let's talk more about that theme of kind of increasing human productivity with AI. In 2020, you founded U.com. And in July of this year, you announced $25 million in funding to empower the world to build the next best search experience. So tell us more about that. How has U.com evolved since you founded it, and what can we expect to see with this recent investment?
Yeah, thanks for asking. So I think it was clear to me for almost a decade now that you could build a better search engine. But when I just ended my PhD and I kind of built some prototypes, I thought, oh man, this is just a little bit too audacious of a project. And I ended up building a B2B company of MetaMind, but I couldn't quite shake the idea off that really it is something that's possible about summarization. It's about giving users control over their information diet, which is becoming more and more important. I think it's important for people to have some control over their information diet through these apps that we have on u.com, different news apps, but also apps like Stack Overflow. And some people hate or love Geeks for Geeks or W3 School, and they want to say, I want to see that, or I don't want to see that. And that is very important. So the current state of search is basically what you see here with Google. I'm trying to get the Python Fibonacci direct computation function, and I see a bunch of blue links. And I can open like a bunch of tabs now and try to figure out my answer. But if I go to u.com, what I will see is a filter. So it realizes Python is a programming language. It wants me to it allows me to now filter all my programming and code snippets, which we have for this programming language. And then it shows me the right answer right here and a copy and paste button, and I'm done. And here's another function that computes it differently. And again, copy and paste button, and I'm done. And then if I want to learn more, I can see this and I'm like, oh, wow, look at this. There are different ways of computing these kinds of functions, space optimized, dynamic programming and whatnot, recursive. And so that to me is the future and very emblematic and representative of how much better you can be for a lot of searches, not for every search. There is also the reality that some of search is just a utility, like water or electricity. You depend on it, it matters, but only while you have it. And then it sucks when it's gone, and then you complain. But while you have it, you don't really care about the details of where your electricity or your water comes from. At least most people don't. And so for those, we also just have to be very, very strong, which makes it an interesting and challenging startup to found. Because in startup land, you usually want to tell people, focus on a tiny, tiny niche, dominate that niche, and then expand from that niche. That is very hard with search, because in search, you actually, even if you're focused on developers, I sometimes jokingly say developers are people too, right? They don't want to go outside. They want to find restaurants. They want to know the weather. They want to get directions. So we had to build over 200 apps, which we're kind of amazingly been able to do to capture all of these other capabilities that people just expect from a modern default search engine. So yeah, I could talk about this for a long time, but I'll leave it there.
So focusing on that niche of developers and helping people write code while still servicing all their needs, of course it sounds super challenging, but I did want to dive in because you've been doing some really cool stuff specifically for developers and at the intersection of code and large language models. I mean, we've seen amazing progress recently in the field with code completion models like GitHub Copilot, Codex from OpenAI, and this is really changing what it's like to be a software engineer. And I wanted to understand, how is u.com thinking about that technology, taking advantage of it, integrating it into your products?
Yeah, great question. We actually are super excited about all the NLP progress in the last many years. And it's one of the many reasons we started u.com. And so we are incorporating large language models in multiple ways. One is if you wanted to write an essay, actually have u.com/write, where you just say, oh, I want to get a quick paragraph about this or that. And I'll just show you an example really quick because it makes more sense. So I was to go to u.com and I say how to write well or write this kind of essay, then I can say, oh, I want to write something about AI and maybe the US economy, and I want it to be a blog post. And then I can basically generate here this entire blog in just a few seconds, and then have it kind of basically be usable for school or for a marketing or a website. I actually use this too because I'm very bad at just kind of generating sort of fluff that have very specific focus points, which works well for academic writing, but not normal people writing. And so this is just like an incredible application that I think really pushes that boundary of how far search can go and how much search can actually be a helper for a do engine, not just a search engine, and really help people gain productivity and help them save time rather than lose time. And similarly, we have a bunch of different code completion apps for like Kubernetes and SQL and regular expressions and all of that. And you can see this here. This is, how to sort dictionary by value. And you can ask the AI if you didn't like your Stack Overflow answer, and the AI will just kind of write this code snippet for you right away. And again, you have a copy and paste button, or you can share it. So to me, those are examples of how NLP, and especially recent breakthroughs in large language models, can help people be more productive, and how we can build a better search engine than anyone else. And we see this in other places. We actually have an open platform now, so other companies can also contribute apps to the ecosystem. And one that is particularly exciting that just launched actually last week is Loria. And Loria uses large language models to summarize thousands and thousands of user reviews. And so for them, and again, I'll just show you a quick visual on this to help them, help this make sense. Here you can see essentially these user-generated, AI-generated summaries of user reviews about different products. And that helps them kind of be more efficient and go and tell people exactly what they need to know about a particular, set of headphones. And so that to me is another example of using, large language models, but also making it so that everyone can contribute. And, that is part of the search engine you control, and being sort of an open platform. It allows everyone to not just vote on their information diet passively, and then see that kind of the right information that they care about, or the right sources like Reddit or Twitter or not, or TikTok or not. There's a lot of strong opinions about any of these, but to also actually contribute back to that first page on the internet. And that to me is something that in a lot of AI applications, people don't think enough about. Feedback mechanisms and ways to contribute and change how the AI works for you, rather than you working for the AI.
What I think is really interesting about what you said, and in general the productionization of these products powered by large language models, is it does seem like sometimes there's a fundamental tension in that what we're seeing in the research literature is, as the models get larger, they get better, right? As you train on more data, as the models get larger, they just get better and better and better. But that also has real latency implications that really impact how you build a product. And you all at u.com obviously think about latency a ton. It's always been very fast when I've tried it. But how do you balance having more accurate results with something that's fast enough for a user to interact with?
It's a great question. Indeed, in search, you can build the best amazing search engine. If it takes 10 seconds to load, it's dead in the water. So every millisecond counts. Every other search engine has either learned that lesson already or is currently learning it. And so you can't actually use large language models to fully replace the actual underlying search infrastructure. When you want to write an essay, you're okay waiting for 5 to 10 seconds like we just did, because it would take you an hour to do it otherwise, or maybe longer, right? But if you just want quick results, it has to happen. Also, large language models would need to have access to a bunch of APIs, right? Like a large language model isn't going to tell you what's the closest restaurant to where I am right now, and is it still open? So we have to have these API integrations, and we have like over 200 such apps now, and some of them we called ourselves, and some of them we work with partners. And so I think large language models aren't the only answer to search. They're an aspect of search. We're incorporating it. We're trying to make it really exciting and use it whenever it makes sense. Same with code snippets. They're shorter. Usually the description is shorter, so you can very quickly throw that in there. But it also costs money. It costs money to run these models, even for a bunch of short snippets. Everything aggregates when you do it hundreds of thousands of times a day or more. And so you need to, maybe sometimes click on the button before we generate it, just in case you really wanted it. And the code snippets that we already show you aren't yet the right ones for you.
And so what do you think this looks like if you zoom out, 10 years from now? This experience that you've been building, there's large language models playing a role. There's all the API integrations playing a role. The indexes you've built. Is there, do you expect those language models to maybe interact directly with those APIs in the future? How much will be driven by the user? How much will be driven by machine learning? And how much will be driven by the core infrastructure that you've built and the content on the internet?
So everything starts with the user every time. But I think we will see a lot more productivity, and a company like u.com that understands this technology, understands what people want, and then help them actually do it. And so for us, these AI code completion features, the essay writing features, or the food ordering features. We have to eat also a way to find the cheapest option often across different delivery mechanisms and just have it delivered to you right there. Those are all do engine apps that help you get something done. And if you extrapolate that and you see what other startups are doing, you can actually probably learn a lot more actions to be taken for you by this one engine. And you can think of almost anything that people do online. You can describe what you want, and have the AI figure out the details, figure out the steps, put multiple things together, multi-document summarization, multi-site actions being taken by that original engine. And at that point, it becomes less and less of a search engine, more of a do engine. That is ultimately our vision. And I'm careful about how far I want to extrapolate and say this is going to come out next year, and then it takes 5 years or something. So I'm very cautious about it, but I am very excited about all the progress we're making on this front.
Super cool. And I feel like you come at this from a unique vantage point, because in addition to your extensive background in machine learning and your background building U.com, you also are an investor with AIX Ventures. And so you see a lot of the broader machine learning and AI landscape of all of the different things that people are building with these powerful new technologies. So I think we've seen it from healthcare in your experience to NLP to search. Can you talk to me about what you see most exciting in the landscape right now? Where are the biggest transformations happening?
Yeah, I love AI and all of its different facets, and I'm so grateful that I can help other people also have this impact in the industries that they want to impact. And I think we see massive impact in AI in healthcare, like you said, but I'll give you maybe a few examples and then talk about AI in agriculture and robotics too. So AI in healthcare, one of our common friends, Janae, who started at Filas, just found this really laborious task of counting red and white blood cells in blood measurements, right, in the blood samples. And it's obvious when you look at the image that a convolutional neural network can do that. It does not have to be a lab technician sitting there and counting these cells. But then you also actually expand and look at the whole workflow, look at when is this test actually being taken, realize that you have to go to the hospital. It would be better to do it at home. And then if you can do it at home and it takes only 10 minutes because AI made that whole process so much more efficient, the whole tool can become a companion diagnostic. So you can actually take the right amount of chemotherapy or other kinds of drugs that change your red and white blood cell count and hence improve the entire treatment. And so that to me is a good example of, you could have just taken the lab technician one example or one workflow and say, all right, we'll just count the cells. That would have been a decent company, but it wouldn't have been the unicorn plus that they are now. But looking at the underlying needs for when is this test taken, what is the full workflow, where is the full value chain, how can you actually improve this, has been incredible, right? And then because if you're already in chemotherapy or you have other immunocompromised issues that lead you to take this test, you don't want to go to the hospital. So it's 1,000x better just be at home, not with a bunch of other sick people that could potentially kill you if you're in the middle of cancer treatment, and you can be able to do this test at home. So those are examples of just beautiful AI improving people's lives. And yeah, so I love AI in healthcare for that. About a third of all of our investments are in AI in healthcare. There's a ton more of course, we know these diabetic retinopathy images, so a lot of stuff in images, but we also have to acknowledge that a lot of the hype around, we're going to replace radiologists did not happen, right? And where AI has most impact in radiology is actually in the speech recognition, and then the natural language processing of automating, extracting information, helping you after you basically dictated the findings as a radiologist. The AI can now summarize it and do, extract the findings and do a couple of other steps that take you another 10, 20 seconds as a radiologist. AI did not yet replace the full radiology workflow. And that will take a long time because there is not that much training data. And there are always new things that can be found. and things that are missed, and areas of new diseases being discovered, and so on. So there's some hype, but then obviously also a ton of impact. And then whenever that's the case, it's very hard to write about it as a journalist and so on. But anyway, AI healthcare, I could talk about it for a lot more, but I think agriculture is also really interesting. You hear from farmers that they cannot find enough people who want to work in the field. And again, I'm not surprised. It's a really hard job, right? It's like in the sun, you're sweating, it's hot, and you have to pick one berry at a time because blueberries are, very finicky. Or you have to cut vines. There's a company that just cuts vines in vineyards. And it's just one of those many jobs that you can make much, much more efficient with robotics and a little bit of computer vision. And then also more complex, actually picking fruits and so on, will happen, and just makes the economy more efficient, gets everyone food. There's less food waste because right now, actually, there's statistics, depending on the fruits and so on, 10 to 20% of fruits are going to waste because the farmers can't find enough people to pick them because it is just not a popular job. And so those are examples where what I look for are sort of mega trends, trends where even if that startup makes a few mistakes, the space itself is growing so much that you can still have a very high likelihood of success as a startup. And I think agriculture, automation, NLP, I'm an early investor in Hugging Face too. They've been doing phenomenally well because there's this mega trend of deep learning for NLP that I've worked on for over a decade now. That obviously will have a ton of impact on many different companies that can use it. And so these mega trends is what I look for. And then, of course, sort of the standard VC checks of go to market, is the technology right, is the team right?
Yeah, what I think is really interesting about what you mentioned is so many of those applications, they have this property that you can't automate the whole thing easily with machine learning. It's only part of the problem. And I think, you and I have both seen this, working together and just in the industry, all these applications where ML can dramatically improve one part of the life cycle, but to really achieve full value, it's got to be sort of working in tandem with people. And speaking of working with people, I wanted to transition into how you've built these machine learning teams at all the different organizations you've been a part of, from MetaMind, where we were together for a period of time, to Salesforce, to U.com now. A lot of people are struggling to build great machine learning teams. And can you share, what learnings have you had along the way?
Yeah, it's an interesting one. And it actually changed over time as well. And it highly depends on the kind of organization you want to build. Early on, we needed very strong developers and actual AI and math expertise at MetaMind in MetaMind days, right? Because there's no PyTorch yet, there's no TensorFlow yet. If you wanted to build a CNN, a convolutional neural network that is very efficient, you have to be in C++, and it's a very different world. It was a very different world back then. You had to actually sometimes even derive the gradients yourself on a piece of paper and then do it to get your backprop derivatives and equations out. So that has obviously changed massively. We are now able to do pretty much everything in Python. There are very few experts that still have to go into the CUDA kernels nowadays to really make things more efficient, and that has changed hiring. One insight, I think, for Salesforce, it was a unique opportunity and situation in that we both had a fundamental research team and lots of different applied AI teams across sales and service and platform and search and all these other applications of AI within Salesforce. And so the research team, we hired just very strong PhDs who had good track records or very young people who already had papers and obviously didn't need a PhD in order to do impactful work. And we let them kind of implement a lot of things. But during that course, we've had several exciting things. And for many years, we had the best language model. And I always suggested to the first author who wrote these incredible language modeling papers with pointers that could copy words over and things like that. It's like, hey, why don't you just scale this up? And he's like, it's a lot of engineering work, and researchers at the time prefer to write a paper every quarter. So I'm like, I didn't want to force him to just do a ton of engineering. So I was like, okay, well, I guess it's not going to happen. Back then, as a research sort of manager, I just wanted to also have academic freedom for the people on the team. But this is maybe somewhere where I changed and learned, because looking at OpenAI, they have a handful of really strong researchers and then a lot of very good engineers who don't want to and feel the need to publish a paper every quarter. They're like, oh, this is impactful, I'll just implement it. And so they were able to like really scale, for instance, language models up, and then actually interesting things happened. And so I think that is also a lesson for other organizations. Very often now, if you have a really strong engineer, the levels of abstraction, the tooling have gotten so good that you don't need to really go into all the math of deep learning in order to have a lot of impact and to be able to engineer very large-scale solutions for parallel training, massive sort of data set wrangling, labeling, of course, scale and others. You don't need to necessarily be a very deep AI expert to be able to have a lot of impact as an engineer in those worlds. And we see similar things in .com, where we've been able to ship features and we can use all the tools and other kinds of capabilities to basically get these things shipped out the door and having impact directly. So at U.com right now, we're not hiring researchers. As much as I love research and I sometimes miss it, I want to build a really great sustainable company that helps real people and end users be more productive, have better privacy, save time, and all of that. And so we're focused on hiring engineers, but we've also found that the really, really good engineers, they are so smart, they can pick up a lot of these tools very quickly nowadays and actually ship incredible models.
It makes a lot of sense. And I think we found the same thing, that it's much easier to teach a really strong engineer some PyTorch than to get a really strong researcher to write production quality code. But obviously having sort of investment in both of those areas can really help push the state of the art forward, as it sounds like you have a lot of experience with. Building on that, what advice would you have for ML engineers, aspiring ML engineers, or folks who are looking to maybe build their own AI-focused startup someday?
So, of course, I wouldn't be a good CEO if I didn't mention U.com. I think that is the best search engine for you to get the right code snippets, the right information quickly, the right tutorials and explanations and so on. I think it's also, taking that hat off, and in general, it is always helpful to invest in your education. And that education is becoming easier and easier to access, right? If you know absolutely nothing about machine learning, you want a really soft intro, then, Andrew Ng's Coursera course, actually very first iteration, I helped with some of the problem sets there way back in the day. This was still MATLAB days, and then Octave, I guess. I'm sure they must have switched it to Python at this point. But that kind of class is a really great intro to understand a lot of the different high-level concepts, unsupervised, supervised learning, and all of that. And then there's so many more advanced classes, the Stanford NLP class and Vision class. They're all, I think you've also worked on that in the past, they're all publicly available. So it's actually incredibly easy to do this. And then what I would encourage everyone is to actually define a project and just build something, have some fun, whatever it is. Maybe you want just a squirrel detector on your camera or something. Try to see if you can actually mark up a couple of examples of the squirrel when it runs through your camera, and then see if you can just build it, put it together. And then it depends on how deep you want to go in the stack. You can have impact right now. Actually, I think you can actually have more impact in AI applications more easily than in the pure research side. In some ways, in pure research, not that much has happened. Transformers are very good models. I think if honestly everyone just try to focus on scaling up LSTMs, we'd probably get into similar levels. It would just be less efficient with their current hardware. And so you'd have to pay more for it and wait a few milliseconds longer at inference time. But the models have been there. The main idea of scaling the model, scaling all your infrastructure and your data sets, and making sure you have a ton of training data for ideally unsupervised pre-trained models and so on. All those ideas have been around for a long time in terms of fundamental research. Now, of course, stable diffusion has also been around for a long time in its early days, but in the last few years, sort of merging the idea of the latent space having word vectors with the decade-old idea of diffusion that has created some more innovation in generative art. But outside of that, most of the fundamental research ideas have been there. And now you can have a lot of impact on scaling these models and then applying them to different industries. So as an ML engineer, I would think about the mega trends that are happening, efficiency gains for different industries or workflows that you may have as yourself as a developer, which is what we're doing at U.com, but also, thinking about healthcare and so on, and then pick a company and just go at it.
Super interesting. And I honestly personally feel like that's one of the reasons, what you just said is one of the reasons that folks working on pushing progress in ML, having some engineering background is also really helpful, because there are fundamental trade-offs between how much you can accomplish with a given hardware budget, depending on how you engineer your systems and how you design your machine learning modeling. Yeah, to your point, it seems like we're in this regime now where there's a lot of different approaches that will work if you scale them up, but they just sort of have different efficiency curves. And what I've seen personally in the research has been that researchers who are sort of aware of the underlying hardware limitations and advantages and design their modeling approaches around that are shipping papers that end up having a lot of impact, right? And I think transformers are a great example of this. From that to what to focus on as an individual ML engineer, I would ask, how are you thinking about that sort of internally at U.com in terms of the machine learning you build? Is it always working backwards from a user problem? Are you ever sort of creatively exploring, hey, what could we build with this new technology? Because what we've seen is that often there's sort of different approaches, right? Where some folks look at, hey, here's a new technology available, what can we build with it? Some folks start with, all right, here's what our users are asking for, how can we meet it? How do you balance those two things for your product development?
It is mostly what users want and what we could build that is interesting. We saw, for instance, a lot of people add scicolon Reddit to their searches because they want to see what real people are saying. So we can build a Reddit app and then just let you vote on that. And this idea of voting, because some people like Reddit, some people don't like it, right? And so we want to give that agency back to users. So all of those features are coming from users and their needs. There are some examples where we say, wow, this technology is so exciting. Maybe we can run an experiment and see if this will resonate with users. And with YouWrite, we found a small niche of people who absolutely love it, but it also doesn't have a mass appeal for, you don't need an AI writing something for you in every other search, right? It is a very particular capability that if you stumble upon it, great, you use it. And you can then, if you use it a ton, you'll have to pay for it, just like everywhere else. And so yeah, sometimes the features do come from just like, wow, there's so much interesting stuff happening here. And we see this with generative art right now too, right? Like when you search for something, would you want a search engine to generate that something, even if it doesn't exist, right? Or would you not want a search engine to make stuff up, right? Visually, right? Obviously, we'll have to explain it and define it very well as something that's AI generated, but it could be interesting. And seeing all the excitement in one community does make us wonder whether we should include that in a search engine or not.
I think that concept of you see excitement in one research community, how much does it bleed over to another, also underpins a lot of the progress we've seen with regard to multimodal learning. You've worked on this a lot yourself. Now there's obviously a lot more research progress in learning representations that generalize across text and images. Some research groups are starting to take this to the world of software actions as well. I guess maybe as a final question to get your take on, what is the future of multimodal learning and representation learning, both for U.com and in general? Are we moving towards a world where there's one vector for each concept that translates across all the different spaces? Are we going to continue to have these domain-specific modeling approaches for different modalities? How do you think about that?
I think it would be a very exciting world. Like you said, I've worked on this. I had the first paper where we used neural networks to map sentences and images into the same vector space. And ever since then, and before, where I actually had some pre-deep learning papers where we mapped words and images into the same vector space. And I've been very excited about the space. Obviously, the brain does connect all these concepts. Language connects different parts of thought, right? And some thoughts are visual thoughts. So you can close your eyes, think about a visual concept, a color or a type of object like an elephant, and the visual cortex will start firing too, right? It's all distributed in the brain as well. So it does make sense to me to combine it. I think the most interesting combination of modalities is actually something we're going to see, I think, fairly soon in code and natural language. The problem with images for search is that, when you do like even a specific query hundreds of thousands of times a day, and you have to classify millions and millions or billions of images, it is very expensive. And that for a while, I think doesn't work with the scale if the scale is too small. And then like if the scale is very small, you can do it. Then there's this sort of awkward in between where if the scale is larger so that it costs a ton of money, but you don't yet make enough money through every one of these classifications, it's also hard. And then once you have a massive scale again, then you can start doing things again at that scale of images. But where I think we're going to see a ton of improvement is that combination of fuzzy natural language process semantics and discrete reasoning that can happen in code. And so for the longest time, I think the research world struggled with combining these two types of reasoning. Is this an elephant or gazelle or cat or dog or whatever, right? This very continuous, lots of modifications and rotation and variances and so on of these kinds of objects, but it's in a continuous fuzzy statistical space. But then all of a sudden you say, okay, what's, this multiplication or like sum up all the numbers between 1 to 5,000 or, how many people are in this room after 5 people entered, 1 was pregnant, had a baby, and now, 1 died of old age. How many people are in this room? And then there's some math involved with this and some fuzzy reasoning involved with this. And I think if you multimodal learn language and code generation, and you connect that to an actual interpreter and compiler and everything that runs the code, then I think you can get some pretty unique features and capabilities that no AI could have done before. And certainly a large language model by itself, without that coding environment, could also not do, right? If you ask a model that has billions of parameters, does billions of multiplications, what's 365.35 divided by 56? It would not give you the right answer, despite trying to do billions and billions of floating point operations to generate that answer, right? It would not get it right. But if you connect that to a coding environment, now all of a sudden you can get the best of both worlds. I think that's the immediate future of multimodal. And then, of course, eventually, as we get robotics to catch up in terms of the hardware, and then also the sort of sensing and reasoning around the physical world, then we have to get multimodal models going in order to be able to communicate with these models and also get them to be more interpretable, define value functions together, all of that.
I'm super excited about this direction of progress because in many ways I feel like it's similar to how we solve problems ourselves as humans. Oftentimes if you're given a hard math problem, if it fits in a few lines, maybe you can do the multiplication in your head, but at some point the numbers get large enough, you want to write it down or put it into u.com to get the answer for you. So I guess the last question would be, do you think that the current machine learning approaches to sort of statistical learning, this large-scale deep learning, large language models, et cetera, with code generation and NLP and maybe other modalities mixed in, is that going to be sufficient to close the loop on what you described as hard reasoning problems? Or does there need to be a change in the modeling approach as well to tackle some type of reasoning that maybe these models aren't doing today?
It's a good question. I think it will close the gap on a lot of different things, but obviously will not start to be insanely creative and knowing when it doesn't know something or when the code is not efficient to run. There's still a lot more things that we'll have to figure out. We also see this actually already. I was chatting with Peter Norvig a few days ago, and he said, yeah, a lot of this AI generated code isn't that efficient. Right? It's just we learned, whenever you have stacks, you should create another stack and put stuff on it. Because in many cases, that is required, but maybe it's not required in this problem. And so what we probably will see is people writing less efficient code sometimes, but they write it more quickly. And so they are more themselves more efficient, but the code might not be as perfect and as efficient as human-generated code. And you have to kind of continue to iterate on that. But certainly, I think we'll make a lot of progress in natural language reasoning once you can connect it to code, right? And that also in and of itself is a massive space, right? Is it just code that you run locally, or you give the ability to connect to tons of APIs also, like the 200 apps we have on u.com? If you now have access to all of those in your coding environment in some structured form through APIs, OMG, could you like build some incredible AI features that have access to all these apps and deep large language models and can take actions based on those, combine multiple apps, aggregate content? It'll be an exciting next couple of years.
Yeah, I mean, in some ways it ties back to what you started off with, which a few hundred years ago, you had 90% of people working in agriculture, less than 5% today. Maybe 90% of software developers are writing their own for loops right now, dealing with this all themselves, and perhaps in the future that's a small subset of the engineering community. Most are actually prompting a language model, getting most of the code written for them. It's going to be really interesting to see. Richard, thank you so much for spending the time with us and joining us for TransformX. It's been great to see you.
Thank you. Always a pleasure chatting with you.